Our land is a complex system with many vital functions. It feeds us, stores water, and captures carbon from the atmosphere. It is a home for wildlife and preserves traces of past civilizations. But our land is threatened by us. We are overusing it, polluting it, and sealing it under layers of concrete. In the future, our land will have to deal with even more demand for urban areas, feed more people, and manage the impact of climate change. What can we do to prevent this threat to our land? To find a solution, we need to understand and address the dynamic complexity of land systems. Soil is the heart of our land, and as in a heart, the processes in soils are incredibly dynamic. Every piece of land has its unique combination of soils. Climate varies every day and everywhere, having a direct impact on the soil. On top of that, the variety of vegetation and uses of land also contribute to this complexity. As a consequence of the combination of these factors, each piece of land needs to be treated individually. Our current approaches to improving the use of land and preserving it are commonly too fragmented. We are repeatedly addressing just one single aspect of a bigger problem, avoiding the inconvenient truth. In this way, even thoughtful policies and legislation cannot be efficiently applied. To change something, we have to face the complexity, and we need to understand that our actions have a direct impact on the land. Understanding the impact of climate by tracking climate variables is old hat. With today's technology, we can collect more data than we have ever dreamed of in order to uncover the dynamic processes in land. Scientists and computer engineers can use this data. They can collaborate to write mathematical models that simulate reality, providing answers to what-if questions. What if climate changes? What if a forest gets chopped down? This combination of technology and knowledge is fundamental to the development of the missing piece, a system that brings the resulting information out of the laboratory, providing simple answers to complex questions. One approach is the interdisciplinary European project called Landsupport. The project has resulted in a web application that gives each stakeholder, from policymakers to local farmers, highly detailed information on every scale. For instance, urban planners can identify areas to convert to green corridors, reconnecting wildlife populations. For new urbanization, the system gives options for finding the best location without depleting precious fertile soils. Or a corn farmer can run a model based on real-time climate variables to check the water content of his soil. In this way, he can optimize the water cycle, which benefits the environment and his wallet. Through wide availability of the Landsupport system, decisions concerning the land can be made on the basis of clear data, rather than just being guesswork. This system is under development. It will include tools regarding agriculture, environmental protection, spatial planning, and even ecotourism. Some of these tools will refer to the local scale, others to regional, national, or even European scales. Potentially, there is no limit. Let's use our land more sustainably and efficiently in the future.